Almost none of them survive. Over 90% of this species dies before adulthood, not from predators, not from hunger, from their own minds. Alakazam is what remains when a brain grows faster than a body can support it. A creature that gradually abandons muscle, instinct, and even normal perception, until what is left is essentially a biological supercomputer struggling to stay alive. Those that do survive do not simply become hunters. They become structural components of ecosystems. When they disappear, entire natural systems destabilize. This is not a powerful creature, it is a necessary one, and survival begins with a rule no other species lives by. The species begins its life far from civilization. Offspring emerge exclusively in cognitively quiet environments, abandoned ruins, remote grasslands, collapsed structures where electromagnetic interference has long faded to silence. These are not random choices. They are strict biological necessities. The juvenile form Abra possesses a brain that develops at extraordinary speed. But this rapid growth creates extreme vulnerability. In its earliest days, the creature cannot filter incoming sensory data. Every thought pattern within range registers as noise. Every emotional signature from nearby organisms floods its undeveloped neural pathways without any discrimination. In populated areas, this bombardment proves fatal. The infant brain cannot differentiate signal from static. Cognitive systems overload within hours. The organism simply shuts down. Only in isolation can development proceed safely. The parents, if they survive long enough to reproduce, select nesting sites based on psychic silence rather than physical shelter. A crumbling tower offers nothing structurally, but if the surrounding kilometers are empty of conscious minds, it becomes sanctuary. Here, in the quietest places still remaining on this earth, the species takes its first fragile breath. And even there, existence is almost lethal. The newborn Abra sleeps. It sleeps for 18 hours each day, sometimes more. This is not laziness or mere vulnerability. It is the only mechanism that prevents total neural collapse. During waking hours, the juvenile brain operates at levels that would destroy most organic tissue. Synaptic activity reaches temperatures that require constant cerebrospinal cooling. Neurotransmitter production exceeds what the body can sustainably manufacture. Every single moment of consciousness burns through metabolic reserves at catastrophic rates. Sleep provides the only viable solution. During dormancy, the brain enters repair cycles impossible to achieve while processing external information. Damaged neural tissue regenerates. Depleted chemical reserves slowly rebuild. The thermal load dissipates through the skull into the surrounding air. Without this extended dormancy, the brain would consume itself within weeks. Laboratory observations of artificially stimulated juveniles confirm this finding. Subjects denied adequate sleep exhibit rapid cognitive deterioration, followed by complete systemic failure. The creature is not resting, it is surviving. Each waking moment represents genuine biological risk, and the organism has evolved to minimize that exposure through enforced unconsciousness. Sleep here is not recovery, it is continuous life support. The juvenile brain perceives everything. This is the central problem of early development. Adult cognition relies on sophisticated filtering systems that prioritize relevant information and discard noise. The young Abra possesses no such architecture. Every sensory input arrives with equal weight. The rustle of grass registers with the same neural intensity as an approaching predator. Distant emotional signatures from organisms kilometers away flood the same neural pathways as immediate physical threats. This creates a constant state of potential overload. The brain cannot determine what matters. It processes everything simultaneously, dedicating equal resources to trivial environmental data and critical survival information. The metabolic cost is enormous. The cognitive strain is even worse. In practice, this means the juvenile cannot function in complex environments. A forest teeming with life would generate thousands of simultaneous inputs. A populated area would produce millions. The brain would attempt to process all of them, allocating attention and energy indiscriminately until the entire system crashes. Survival depends entirely on environmental simplicity. The fewer signals present, the longer the organism can remain conscious. The quieter the surrounding world, the greater its chance of reaching the developmental stage where filtering finally becomes possible. But survival creates a new crisis. The brain does not stop growing. As the brain grows, the body must adapt to contain it. This transition marks the shift from Abra to Cadabra, and it is fundamentally an engineering problem solved through radical structural change. The expanding neural mass requires physical support that the juvenile skull simply cannot provide. Over several months, the cranium thickens dramatically. Bone density increases substantially. The structure reshapes itself into an elongated form that distributes weight more efficiently across the spinal column. Simultaneously, the spine itself undergoes reinforcement. Vertebrae fuse in critical sections. Supporting musculature develops along the neck and upper back, though this tissue will later atrophy as telekinetic systems assume locomotive functions. The immediate priority is structural integrity. Inside the skull, compartmentalization begins. The brain divides into specialized regions, separated by newly formed membrane barriers. This prevents cascade failures. If one cognitive sector overloads, the damage remains contained rather than spreading through the entire neural network. The process is visible externally. The creature's head elongates over weeks. Its posture shifts as the center of gravity moves upward. Movement becomes slower, more deliberate as the body adjusts to carrying mass it was never originally designed to support. The organism is rebuilding itself around its most vital organ. Everything else becomes secondary infrastructure, and eventually, even that infrastructure becomes unnecessary. The Cadabra stage introduces a fundamental shift in how the organism interacts with physical reality. Muscles become obsolete. The mind assumes direct control over all movement and external manipulation. Telekinetic output emerges as the brain's electromagnetic field strengthens beyond passive reception into active projection. The creature discovers it can manipulate objects without physical contact. Initially, this manifests as clumsy interactions. Small items tremble. Loose debris shifts unpredictably. The organism is learning to extend its will into the environment. Within weeks, precision develops. The creature begins using telekinesis for basic locomotion, lifting its own body rather than walking. Limbs atrophy from disuse. Muscle mass decreases. The energy previously dedicated to maintaining physical mobility redirects entirely toward cognitive function. This trade creates new burdens. Every telekinetic action requires neural processing. Moving an object demands the same cognitive resources as complex problem solving. The brain now handles both thought and motion simultaneously, doubling its operational load. To manage this strain, the organism develops external focus tools. Mineral deposits with natural conductivity are shaped through sustained psychic pressure into implements resembling spoons. These objects act as amplifiers and regulators, channeling telekinetic output more efficiently than raw projection allows. The body has become a vessel. The mind has become the engine. Physical strength no longer matters in a creature that moves reality with thought. Constant cognition demands constant fuel. The cadabra brain consumes calories at rates that challenge biological possibility. Standard metabolic processes cannot keep pace. The organism requires continuous glucose delivery to neural tissue, yet digestion operates on cycles measured in hours. This mismatch creates perpetual energy deficits. The brain begins cannibalizing other bodily systems just to maintain function. Muscle tissue breaks down first, providing emergency protein conversion. Fat reserves deplete rapidly. The creature grows thinner even while consuming massive quantities of food. External observers often mistake this emaciation for illness. It is simply the cost of running a biological supercomputer. Failure cascades quickly when reserves exhaust. Neural tissue deprived of glucose begins dying within minutes. Cognitive function deteriorates in predictable stages. First, telekinetic control weakens. Then, sensory filtering collapses entirely. Finally, consciousness itself fragments as higher brain regions shut down to preserve core autonomic systems. Few organisms recover from this state. The brain damage is typically irreversible. Those that survive often lose decades of accumulated cognitive development, returning to juvenile processing patterns. Feeding is not a choice for this species. It is an unending biological emergency. Every meal delays neurological collapse. Every missed opportunity accelerates the countdown toward failure. Only the individuals that stabilize this energy crisis reach the final stage, and what emerges no longer experiences the world in real time. The fully mature Alakazam perceives the world differently than any other known organism. It no longer relies on direct sensory input. It predicts. Through decades of accumulated environmental data, the adult brain constructs comprehensive mental models of its surroundings. These models include terrain, weather patterns, prey movements, and threat behaviors. The organism updates these maps continuously through minimal sensory sampling, reducing exposure to the overwhelming data streams that endangered it during its juvenile development. In practice, the creature often acts before events occur. It relocates moments before a predator arrives at its position. It intercepts prey along routes the animal has not yet chosen, but statistically will. Observers describe this as precognition. Biologically, it is simply prediction operating at computational scales beyond normal perception. This capability transforms how the organism inhabits space. It does not explore. It already knows. New environments require brief, intensive scanning to construct initial models. But once mapped, the creature navigates almost entirely through internal simulation. The external world becomes a confirmation system rather than a primary information source. The Alakazam lives substantially inside its own mind, touching physical reality only when necessary to verify its predictions remain accurate. Mature individuals maintain vast distances between themselves. This is not aggression or territorial dominance, it is survival engineering. Two Alakazam operating within close range create immediate problems. Their electromagnetic fields overlap. Cognitive outputs interfere with each other's sensory systems. The predictive models that both rely upon become corrupted by the other's mental activity, bleeding into their perception. The effects escalate rapidly. Feedback loops develop as each organism attempts to model the other's behavior while the other simultaneously models them. Processing demands spike dramatically. Neural strain approaches overload thresholds. Neither creature can function effectively while the other remains present. In extreme cases, proximity triggers cascade failures in both organisms. Historical records describe paired collapses where two individuals encountered each other unexpectedly, and both suffered immediate cognitive breakdown. Neither survived. Natural spacing solves this problem. Territories extend for dozens of kilometers in every direction. The creatures sense each other's presence at range and adjust positions to maintain buffer distances. They share ecosystems, but never share space. Solitude is not preference for this species. It is biological necessity written into the fundamental architecture of how their minds operate. Reproduction occurs rarely. The costs are extreme, and the failure rate is catastrophic. Mating requires proximity that both individuals find cognitively dangerous. Brief encounters minimize exposure, but even temporary overlap strains both participants severely. Many breeding attempts end with one or both adults suffering partial cognitive damage that requires months of careful recovery. Offspring present additional and unique challenges. The newborn emerges with latent psychic capacity that activates gradually over its first weeks. During this activation window, the juvenile cannot shield itself from parental mental output. A fully developed adult mind nearby would overwhelm the infant's developing neural systems before filtering architecture could form. Parents must therefore abandon offspring immediately after birth. The juvenile survives only if left entirely alone during the critical stabilization period. Any attempt at nurturing, protection, or extended contact proves fatal to the child. This creates a species with no parental bond whatsoever. Adults never know their offspring. Juveniles never encounter their parents. Each generation develops in complete isolation from the last. And yet, entire ecosystems quietly organize themselves around their existence. In balanced ecosystems, Alakazam function as invisible regulators. Their predictive hunting maintains prey populations without causing collapse. Their territorial spacing distributes influence evenly across landscapes. Predator species cannot establish dominance where a mature psychic hunter already operates. The effect is stabilizing. Population cycles smooth out. Boom and bust patterns diminish. The ecosystem finds equilibrium around an apex organism that removes only what its models determine the system can sustainably afford to lose. When Alakazam vanish from a region, the effects manifest within seasons. Prey populations surge unchecked. Competing predators expand aggressively. The entire system oscillates into instability. Where too many congregate, the opposite occurs. Overhunting depletes critical populations. Territorial conflicts produce casualties. No ecosystem can support multiple cognitive apex predators drawing from the same resource base. Balance requires their presence, but only barely. One mind watching. One invisible guardian calculating what lives and what must not.